Okay, folks, well, how do we deal with SOHCAHTOA or trigonometry? It's three functions in the beginning, and you might say, what are you talking about in the beginning? This is a really deep topic, and the three functions we have are sine, cosine, and tangent. And I have these written on the whiteboard, but the O stands for the opposite leg and the hypotenuse, and that's what we got going on in this situation. From the 57-degree angle, we have the opposite leg, and then we have the hypotenuse over here. Right across from the right angle is always the hypotenuse. So that's what the O and the H stands for. If we were dealing with the adjacent leg down here, then we want adjacent and hypotenuse, right? Because the hypotenuse is definitely the one we want. And then if we had, let's say, the X down here on this leg, then we'd be wanting the opposite and the adjacent leg. But since we care about the hypotenuse, we're either going to choose sine or cosine. And honestly, you could go to cosine if you found this angle right up here. And this angle is 33 degrees, because all I got to do is take 90 minus 57, and that gives us 33 degrees. See, this angle right here is complementary with this angle down here, because we've already used up 90 out of the 180 to use for a triangle, right? So if I subtract 90 from that, I only have 90 left between these two angles. So anyways, if I find this angle up here, then I could use cosine, because now this is the adjacent leg to the 33-degree angle. So I've got to change it to adjacent leg if I'm going to use the 33. So let me put that down here real quick. Cosine of 33 is equal to 5 over x, or if we use the 57-degree angle, then this is the opposite leg. So I'm going to put adjacent to 33, and it's the opposite leg to 57. Remember how I had my eye right here? Like, what am I focused on? I'm focused on the 57-degree angle right now. But if I move this eye, oh boy, let me see if the program will let me do this. Yeah, this is always an issue, like just trying to get the eye and nothing else. It thinks I want the whole picture. But if I put the eye right up here, now this is my adjacent leg. Okay, so if I use where the eye is sitting right now, I would want sine of 57 degrees. 57 is equal to 5 over x. Now, I don't know. I mean, looking at both options, sometimes students can get confused. So maybe I'll clean this up a little bit over here, and we'll only worry about the 57-degree angle, okay? So nix this idea, and we'll just do this one, because it wouldn't matter. Either one's going to require the same amount of work, all right? Now I'm going to do a little arithmetic here, or algebra. So on the right side of the equation, I'd like to multiply this side by x, so I don't have an x in the denominator, but I have to multiply this side by x also. All right. Oh, and by the way, I call this thing right here the setup. All right. I'd love to see a setup on your homework today, in your notes, in your notebook, for each one of the problems. Okay. On the test, it's going to be required. Now, once I have the setup, I'm multiplying both sides by x so I can get the x out of the denominator here. These divide out to 1. And on the other side, I have now x times the sine of 57 degrees is equal to 5. Now what I'm going to do is I'm going to divide both sides by the sine of 57. So sine of 57, sine of 57. These guys right here divide out to 1, and I'm left with x equals 5 divided by the sine of 57. Now I want you to compare this final line. This is what I'm going to type into Desmos. I'm not going to put the x equals part, but I'm going to put 5 over sine 57. I want you to compare it to where we started. Do you notice how the x and the sine of 57 have traded places, more or less? We swapped them. Because if you think about it as a proportion, like a fraction equal to a fraction, these two are going to get multiplied together, whether x is down here and sine 57 is up there, or x is over here and sine 57 is down here. Now, why is this better? Well, we were looking for x. So I'm jumping over to Desmos right now. I need you to do the same thing. Open up a Desmos for me. And we're going to, first thing off is to change to degree mode. I don't know, maybe there's a way to like set the default to degree mode, but I don't know what it is. And let's go over here and let's look at what our final equation is, 5 over sine 57. So I'm going to go 5 divided by sine 57. If you don't get 5.96 after typing that in, you're in the wrong mode over here. You're not in degree mode. It needs to be black on degree. So if I change to radians, that's the answer you get. That's wrong. If I'm in degree mode, 5.96 something. So let's jump over here. It says to the nearest tenth. So 5.96 to the nearest tenth, there's the tenths place, right? This is above halfway, so I'm going to make it 6.0 on my problem. Let's see, should I write right here? 6.0. I don't know if you'll need the 0.0. They probably would just give you credit if you put down 6. Boy, I hope I'm making that clear. You got like 3 problems just like that, right? Now let's look at ones that have a drawing, you know, some stuff that we need to ignore, right? And I've told you guys before, think about like ignoring a bunch of stuff. Like, do we care about the roof over here? You know, we don't care about any of that stuff, right? How does that have anything to do with the problem? But I think sometimes our eyes get like sucked into that. You know, we don't care about any of this stuff over here, right? We don't care that there's a door here. You know, so you really have to ignore a ton of information. Now we see the triangle that we care about. We care about this side right here, right? I'm going to put an X on that side. And boy, this is looking a lot like that last problem, except that the hypotenuse this time is a side we know, and the opposite leg is the side we're looking for. So I'm going to again use the SO part of SOHCAHTOA, and I'm going to say the sine of 63 degrees is equal to X, the opposite leg, over the hypotenuse, which is 14, okay? That's what the O and the H stands for, opposite over hypotenuse. Now there isn't the word over here, it's just understood that, you know, this is the sine function, it's the opposite leg over the hypotenuse, okay? Now I like these where X is in the numerator because all I need to do, oh, let me change to red here just to show you this is my algebra. Oh, wait, let me go back to black. This is my setup. I definitely want to see a setup in your notebook, okay? So there's my setup. And what am I going to do to both sides? I'm going to multiply both sides by 14 because now the 14s are going to divide out to 1. And so I got to multiply this side by 14. And the part I love about Desmos is, look, my final answer comes out to be 14, exactly 14 times the sine of 63. So when I jump back over to Desmos, I have maybe some of that stuff in there, right? Like I've got the sine of 57. I just don't want the divide by sign. I want 14 and I want 63, so I want 14 here and I want 63 over there. I would suggest you try and delete, like don't delete this way, just try to modify what you have over here for each individual problem, right? Or maybe make a couple different lines of work, and then when you do a new problem, choose which line of work you want back over here on Desmos, right? So you don't have to start clean. It's 12.5 if I'm round to the nearest tenth, right? So let me just double check it before I type it in. Okay, I think I got 12.5 for that answer. Okay, so 12.5, and then I'd love for you to show me like it's approximately equal to 12.5. This is what your homework looks like in your notebook. Okay. All right. So last problem. Well, maybe I have 2 more to do with you. This is brand new, and we didn't talk about it yesterday. But when you think about it, like look, let's jump over to Desmos for a second, okay? Sine of 63, what the heck is the sine of 63? It's about 0.89 something. So what we're saying is, if we had a 63-degree angle, like we had in this drawing, the opposite leg to the hypotenuse is in a ratio that would be equivalent to 0.89 something. So don't you think there would be a way to go the other way? Like if we told the calculator, hey, the ratio of the opposite leg to the hypotenuse was 0.89 something, tell me what the angle is. And here's the way you do it. You go sine, and I'm raising to a power, and this is a little tricky. You can hear the hesitation in my voice. I'm hitting Shift 6 to raise it up to a power, but it's really not an exponent. I know you might be saying, yeah, it is. It's up there in the exponent. But Desmos has been programmed to understand this -1 is just saying, let's go the opposite direction. Instead of telling me the ratio here, tell me what the angle is, and what you do next is, oh, you don't want the parentheses there, you got to arrow out of the exponent, and I would put it in parentheses, and I'm going to put like several decimals here, 0.8910065. Hey, look at this. The more decimals I put, the closer it gets to 63 degrees, right? So what it's telling me is the angle if I tell it the ratio. Hey, let's try one. What if I did the inverse sine, shift 6, -1, that tells me I want the inverse, oh geez, I got my mouse right on it. So sine with a little -1 kind of as an exponent, and I do 0.5. Have you seen that before, the 30-degree triangle? Right? Do you remember how in the 30-degree angle, the opposite leg to the hypotenuse is half, the opposite leg's half of the hypotenuse? So when you say, hey, I got a triangle with the opposite leg being half the hypotenuse, the computer says it's a 30-degree angle. So going back to our problem, where are we? All we want to do is set up a trig function, and I have what? The opposite, here's the opposite leg, here's the hypotenuse. Boy, it seems like a lot of these are sine functions, aren't they? So I go, the sine of x is equal to 19 over 23. This is just like what we've been doing all along with the setup, right? Here's my setup. And now what I'm going to do is I'm going to say, hey, I want the angle. So I'm going to say the measure of angle x is equal to the inverse sine, this is the way you really say it, inverse sine of 19 over 23. Or sometimes, this is going to be sounding really weird, arc sine. There's no indicator here that you would say arc sine, so I'm not going to say it that way. I'm going to say inverse sine, because we use that -1 for an inverse function. Like, let's say I had the function f of x. If you see f with a little -1 up there, it means inverse. Okay, so this was like my original function, right? And then this is my inverse function down here. So that's really where that -1 is coming from. So I'm going to jump back over to Desmos. So I'm going to do inverse sine of 19 over 23. Hey, look at this. I already have an inverse sine right there. All I need to do is go 19 divided by 23, and I get 55.7 degrees. I come back over here. I think it wants it to the nearest 10th place. So what was it again? 55.7. So I go 55.7. Okay? I think I have one more problem to do, but I really want you to consider trying to delete less on Desmos. That's the cool part about Desmos. You can just kind of keep a running tally of what's happening here. Let's see. I think I got one more to do with you. Yes. Okay, so I just wanted to point out on this one that when it says solve the right triangle, it wants every missing part over here. So we've said that to find the other acute angle right down here, you go 90 minus the one you know. So that's minus 47. I think that's going to give me 43 degrees. So my answer for angle A is 43 degrees. For side B, let's see, I could use the 47, and B is opposite from the 47, and 24 is the adjacent leg. So the part of TOA that I want, the SOHCAHTOA part that I want, is the TOA part, because I have the opposite leg I care about and I know the adjacent leg. So I'm going to go tangent of 47 degrees is equal to B over 24, and then I multiply both sides by 24, so times 24 here, times 24 there. The 24s divide out, and I'm left with B is about, well, let's go over there. I need 24. I guess I don't have one set up with the tangent, so I'll just do it. 24 tangent of, what was it, 47 degrees? Was that what it was? Yes, so 24 tangent 47, and I end up with 25.7. Let me just triple check that I'm in degree mode. That would stink if I've done all these problems in the wrong mode. So 25.7. Okay, so I come back over here and I put down 25.7. At this point, you could switch to Pythagorean theorem, but if you use the 25.7, boy, you're being pretty inaccurate. So one thing you could do, and this is going to be only maybe for super advanced people, is you could consider taking this whole answer here, like right here. I'm going to copy this, okay, Control C, then I'm going to paste it right down here after a parenthesis, Control V, and then I'm going to square that. Okay, so that's one of my legs squared. What was the other leg squared? Let's see, it was 24. So I go 24 squared. All right, now all of this number I need to take the square root of. So one way to do that, oh shoot, hit the wrong parenthesis. Put parentheses around all this stuff. I think I could do this. And then I could raise this to the 1/2 power. This is, like I said, for advanced people, to the 1/2 power is the same thing as the square root. If you don't like that, once you have this all typed in, you could just like cut it. You know, you could go, I want to cut all this, Control X, and then you go, I got an extra like something in there. Let me get rid of that. So I go S, oh wait, there it goes. SQRT, and then I go paste, and I get the same answer. So I'm taking the Pythagorean theorem here. If you really don't like that, what I just did, then you could do, you know, like the tangent. You could say the tangent of, this was 43 degrees, right? So I could say the tangent of 43 is equal to 24 over C. And then we said we could switch these two where their locations are. So I could say C equals 24 divided by tangent of 43. And let's see if we get the same answer down here. So, oh man, it's 24 divided by tangent 43. Uh-oh, something went wrong here. What did I do wrong? 43, 24. Ooh, boy, that makes me a little nervous. 24 tangent 43. 24 tangent 43. It's not coming out to be the same. Oh man, Nelson, come on, you ding dong. I don't want the tangent. Tangent's opposite over adjacent. What am I doing? I want the sine. Oh my, I'm embarrassed now. That's embarrassing. I want the sine of 43. See how, like, if you pick the wrong trig function, you're not going to get the right answer. When I saw that this answer was the same as this one, I'm like, wait a minute, I've got the wrong trig function in here. So I want the sine function right here. 35, oh, there it is. See how it matches up right there with the Pythagorean theorem? So it's super easy to make mistakes. You kind of get going too fast. Just slow down. You know, we knew we needed the hypotenuse over here, and the hypotenuse could be, you know, found by doing the opposite. So now this is the opposite from the 43. I'm using the opposite leg over the hypotenuse. See, I should have just slowed down a little bit. So I made sure that I was using part of SOHCAHTOA again. All right, hey, thanks for watching my video. I hope that's helpful to you.